Hello. In this lecture, we will introduce data types, some basic data types used in C. First, integers. In C, it's called as int. So, as the name suggests, it's for integer representation, numbers like 1, 2, 3, 4, etc. Then we move on to floats. In C, you denote by float. Floats are like real numbers, more or less more like rational numbers, something like the form 23.5, 3.14, etc. So it's rational number. How do you represent a rational number? Using floats, float in C. That will be the second thing. And third thing we will be looking at is called as characters. Char, char, that's for letters like A, B, C. These are letters. Okay, so these are the data types we will be looking at here. But you can, in this lecture, we will be covering this. There are other data types in C, say arrays, for example, pointers, etc., etc. So we won't be covering these things in this lecture, but we will see in subsequent lectures we will be covering these things. Okay. Also in integers, in particular integers and floats, there are also some additional things you can add to some things like in English language it's like adjectives, like so things like that you can add to integers, floats, something like long integers, saying that integers, I mean like bigger integers, you can talk about integers which are bigger in size, short integers like integers of smaller size, etc. Similarly for floats, there's something called as double, basically, which is talking about bigger floats, etc. We won't be looking at these things. Okay, these are once you understand floats, integers, and character, these are, I mean, like, the fundamental types. Then it's easy to pick it up. You can look any of the reference book for C to understand these the other concepts. Okay, so I'll be more or less we will be looking at integers, floats, and character. We'll start off with integers. Okay, bye. Let's say I want to print some numbers. I want to do some addition, multiplication, and print the results. So let's do that. And so again, we start the program. As you could see, it's called the program is named data types.cc, and I want, so first thing, I want the main function and its body. Okay, and since I want to print, I'm going to include #include stdio.h. Okay, now let's say I want to print, I want to assign a number to a variable and print that. Okay, so first thing, how do I assign a number to a variable, right? So let's call the variable var. Okay, I want to assign the number, let's 20, and I want to print this. Now first thing is that for C this is not enough. The two mistakes, so what is it I have tried to do? I have tried to assign the variable called var to the number 20, and I have made two mistakes. This would be correct in Python, but here there are two mistakes. One, I have to put the semicolon. This is something which we told, every statement ends in a semicolon. Second is, I have to tell the C compiler what type of data var is. Okay, so var could be a string, var could be an integer, or var could be a character. So these are string types you will soon see. Var could be a rational number, or something like 2.3, 3.5, etc. So that would require a different data type called float, etc. So you need to tell what kind of data type you are interested in. What kind of data type is var. Okay, and here in this case we want var to be an integer, so I am going to type it as int var. Okay, so I have declared, I have basically I have told the compiler that var is an integer and it's being assigned the value 20. Okay, now let's say I want to multiply var with, let's say, 2 and store it in another variable. Okay, and let's say I want to have something like q is equal to var into 2. So this is var into var, this asterisk 2 would mean var multiplied by 2, and I want this variable q to be assigned this value 20 into 2, that's 40. Now again this is wrong because I haven't told the compiler what type of variable q is, so I have to tell that. So I have to try give that information. Q is an integer, right? And I again do it by int. But this is one way to do it. So there is another way to declare this. I could have declared this thing in the beginning itself. I could have told int q. So this is basically I'm telling the compiler that q is a variable which is of type integer. Okay, so once I have declared this as an integer type, then I can use it for any integer operations. What are other integer operations? I can use it to say that q is equal to q plus 1 for example, or so that's basically I have incremented the value of q, etc. Now let's say now next thing I want to print this. Okay, so what is it, the value of var and q? In this statement the value of var is 20 and the value of q will be 20 into 40 plus 1, it will be 41, right? So I should get var is equal to 20 and q is equal to 41. So let's try to do that. Let's try to print that fact, right? So I'm going to print. So again, print this through using printf, and printf, as we saw earlier, will only take strings. And now I want var is equal to, okay, so this is what I want to do. Let me say I want to do var is equal to this, let's say this variable var should come here. We will this is not the syntax, we'll just but I want to show what we want, and q is equal to variable q, right? The value in variable q. Okay, so okay, the value in var and the value in q should be coming here, right? Now how do I tell the compiler to take here the value in var? Okay, so for that what I will do is I will do write what is called as %d here and comma var. So let's first try to print only var. Okay, so I'll just type var is equal to %d comma var. Okay, and here so the output should be var is equal to 20. That should be the output, and I will add a new line character here so that so our print will take one full line, and then the terminal command will go to the next line. So this is ends with the new line. Okay, right? So this is a command statement, as we have noticed. Okay, now I want to compile this, right? How do I compile this? gcc data types .cc. Okay. So this is, there's some problem with gcc. Okay, so okay, so initially I had I didn't type data types, I just had data types. Okay, the two mistakes here. What are the two mistakes? Okay, I didn't put semicolon here. That's the first mistake being pointed out here, and I didn't put semicolon here. Again, mistake being pointed out here. This is the problem of using Python, doing Python programming and switching to C. you tend to forget putting the semicolon. Now compile, done, good, it has compiled. Now I'm going to run. Yeah, so what do we see? We see that bar is equal to 20 being printed here. That's exactly what we want. Okay, now let's say go to the next step. And what is the next step I want to do? What I want to do is I want to print var is equal to 20 comma q is equal to the value in q, that is q is equal to 41. So I want that, so I'm going to write comma q is equal to percentage d here. Again, as we had told you, it's percentage d comma q. Okay, so the first percentage d will be from this first value var. The second percentage d will be replaced by the value in q, the second parameter being passed. Okay. Now, so to do that, let me compile and I run. It's good. So you can see that var is equal to 20 and q is equal to 41. Right. So this is clear, right? So now another thing. Next is, as you could notice, this is incrementing q by 1, right? So q is equal to q plus 1 basically increments the value in q just by 1. You add q by 1. So there is a shorthand for this notation. So that shorthand notation is you have q plus plus. Okay, that basically says q is equal to q plus 1. There's a shorthand notation, and let me compile that and check again. Again, as you could see, it is q is equal to 41. See, now what if I had written q minus minus? What if I had written q minus minus? I can again compile. See, it's q is equal to 39. So what had happened? Q was originally 40 and it's minus 1. So when you put minus minus, decrements. When you put q plus plus, it increments. Okay. Okay, so let's go back to plus 1 now. So as you could see, we can, so now you want more things here, we can have more things. Let's say I want to have, now I again take q by what else do we want? So you have q, so if you want to do minus, you should have minus like this. So this is you subtract by, so let's say I want to do q minus var. So what do you get? You're going to, so initially it was 41 in q and var is equal to 20, and you should get 21 now. So let's see. You didn't get that because you didn't compile. So first thing, you have to compile. Again, there's a mistake because you didn't put semicolon. So you have to put semicolon, the semicolon. I compiled again and I run. See, it's var is equal to 20, q is equal to 21. Okay. I hope till now things are clear. Now we go to the next thing. So as you could see, q is 21 here. So I'll just have that here. So q is equal to 21 at this point. Now what if I have q is equal to q by 2? Okay, so I'm dividing q by 2, and what should I get? So let me again compile, run. I got q is equal to 10. So what should the answer be? The answer should have been 21 by 2, which is 10.5, but I got 10. Why? Why did you get 10? You got 10 because you told the compiler that q is an integer variable, right? So an integer variable can't store 10.5. So if this was 10.5, so let me type 10.5 here. So I'm going to say q is equal to 10.5, and I compile. It's saying no, this is not correct, because so this is not an error as such to the so it's saying it's a warning, because it's saying 10.5 is not an integer, but you are trying to store 10.5 in the integer. So what is it? It's saying I'm going to convert it into integer and I'm going to change the value from 10.5 to 10. So the C compiler, the C compiler knows that q is an integer and not a real number, it converts the real number back into an integer, and that's what so and how did it convert? It basically goes the the largest integer smaller than that. So uh, what is an integer, largest integer smaller than 10.5? 10. Okay, so you get 10 here. So that's why so as you could notice, the GCC compiler has warned you, has told you that you are making some, I think I mean, you're making some mistake, but I have generated the code. You can still run and see. So the compiler has still give you the file, and you're running it, and you can still see q is equal to 10. Okay. The compiler is telling, okay, good, I have warned you, but still you can go ahead and run. So this is the thing about warning. Warnings tell you that, okay, it's something, I think you are wrong, but you can still go ahead and run. On the other hand, error says that no, you are wrong and I am not going to compile further. Okay, that's the difference between error and warning. Okay, now so you have this. Now what can you do if I want, let's say you want to do this now let's say you want to have 10.5, right? You want to print 10.5, you want to have this not just integer numbers, you want to also have this real numbers, or in this case fractional numbers, right? In C they are called as float numbers. Okay, so in C now how do you want, so now let's say you want to have float numbers. How do you say it's a float number? Okay, so what is the, how do you say something is a float number? You say float, right? Now you say float. Okay, so you have said that it's float, q is equal to 10.5, right? And this should ideally store the 10.5 into the float variable q. So what does float q means? Float q is trying to tell that q is a float number, and it's storing q is equal to 10.5. Okay, just one mistake in what we did. What is that mistake? The mistake is that I had already told the C compiler that q is an integer, and now you're saying that q is a float. No, C won't allow you to change what you have declared. Okay, because it has already allocated and it's already decided that q is an integer, and it has basically done things in its background to make things life easier for the integers to do computation in integers. He has already done things in its background. So now you can't change later and say that no, q is a float. You're not allowed to change. So you should ideally have a different number. So you can have, let's say, float number. Okay, so basically saying the float number is a number which is a float. Okay, now okay, so I have now assigned float number is equal to 10.5. Again, there is one problem, and the problem is that the issue is that, okay, C says that no, you have to declare all your declarations for data type should be made in the beginning. So beginning of the function, so you should basically say it here itself. Okay, so once the declarations are over, you are not allowed to declare. Okay, so you are declared float earlier. So we have now assigned the float number to be equal to 10.5. Now next step is printing that float number. Okay, so to print an integer, I have used %d, and to print a float we'll use what is called as %f. Okay, now let me compile and see. Compile, run. Okay, you could see it's printed var is equal to 20 and q is equal to 10.500. So this is q because here I had q, so let's have it float num just to make things clear. Okay, so you could see that, you can see that float num is equal to 10.5 followed by, so it's basically 10.50000. Okay, why did it print lot of zeros like this? Okay, so it's basically so the C program prints 6 decimal places after the point automatically. So if I want less, what I should do is I should take this thing 0.2f. Okay, so then what happens? Let's see. I compile, I run, it shows only 2 places, 10.50. Okay, so 2 places after the decimal point. Okay, now it's clear. Now if I wanted 3 places, I'll write 3. So it's 10.500. Okay, so it's all up to, so the user can decide how many decimal places you have to write after the dot. The user has that flexibility. Now let's do some more things. Okay, let me just print only float here. So our next aim is to print the value of q by 2. Okay, so I'm going to print q by 2 here and see what happens. Oh sorry, it's q by 2 and see what happens. Just remove the slash because it's already there below. What is it I expect? So as we have noticed here, q is 21 at this point and I expect it to be 10.5, right? Okay, so let's see what happens here. It's GCC. So how do I compile? I compile GCC data types dot cc and dot slash a dot out. It says 10.00. What we should have got is 10.5, but it is 10.00. What happened here? Now the issue is the following. Okay, q is an integer. When I divided q by 2, it should have been 10.5, but the compiler thought, okay, I am dividing an integer by an integer, so therefore I should convert it into the integer, into an integer and not a rational number. So the compiler, so integer by an integer, the compiler will convert it into an integer. So that's why q by 2 becomes an integer, which is 10, and float, which is a float number, gets assigned an integer value. Floats can always get assigned integer values, and therefore float gets the value 10 and it's printed. Now we can see the difference in 2 ways. Let's say I have let me call another float number, float. Let me just put I create one more float number. So I float number, and so this is another way to define multiple floats. Okay, so I just had float num, and I'm going to have one more thing here. Let's say float num 2. Okay, so this is float number 2, and maybe I'm going to have float num 2 is equal to 21, and I'm going to divide float num 2 by 2. Okay, this time what is it we need to get? We expect to get, so we already know that float num is a float number whose value is now 21, and it's the float number is being divided by 2, and we should ideally get 10.5. so let's see whether the compiler finds that thing. Okay, it's saying sorry, you're used to Python and you haven't put the semicolon. Yeah, right, and I have put the semicolon. I compile, I run, and I get 10.5. So you notice the difference. If I had divided by an integer, I would have got 10. On the other hand, since I divided by 21, I got since I divided by since I divided the float number by 2, I got 10.5. Okay. So finally we come to the last data type called character, written as char. So a char data type is a character, a letter, some like this. Okay. Or it can be P, it can be plus, just one letter. So it's just one byte of information. So you could have add A, okay, and we have ch is equal to A, and let's say I want to print it. How do I print that character? I write character is equal to %c comma ch, which is the character name, colon. Okay, and now I want to compile this. I compile as follows. I write gcc cc data type. Okay, there's some error. What is the error? Print. Okay, so it's not print again because of Python. It's printf, and I compile, I run. As you could see, its character is equal to A. Now I could have had something else here. I could have had, let's say, plus. What will you see now? Then character is equal to plus. Okay, so right, so you can see character is equal to plus, right? Now what if I add a string character is equal to ABC, let's say? That's an error. Okay, it's saying that I mean you're supposed to have ch is a character. It's just one letter which could be assigned to the character, but you are now assigning a lot of letters. So C does not understand what is happening, right? And now, but it still did something. It converted something, and now it's printed. It has printed C. Okay, so basically some random thing has happened because of it has thought this character is something, and it just did some things, and then okay, so I mean, so it's basically some conversion etc has happened, and so the last letter got printed. But what has so that's because of some memory allocation, which we will see how in the theory class on how the memory is allocated for each of the variables etc. So but the main point is that now when you have something like this is not a character. A character is basically one letter, say Q, and you can print that. So you can only store one character information in ch. Okay, you can't have a character is not a string of information. That's the main point.